Hello and welcome to Stock Voyage. So last week I made a video about what would have happened if you bought 100 random stocks 1 year ago and held them until now. I made multiple lists with different parameters, but unfortunately I've made one list for each parameter, which you've kindly pointed out. That was mainly because I was doing everything manually and it took me way too much time to just make one list. So instead of giving up and moving on, I decided to solve the problem. The easiest way to make this list fast is by writing a program that would do everything instead of me. So I sat down and watched around 6 hours of Python tutorials on YouTube and started coding, which just made me realize that I have way too much free time. Anyway, in the first part of the video I'll go over the results, and in the second part over how the program works and how you can also write it. So the program lets me choose between most valuable stocks and sectors. If I choose the sector option, the next question pops up. Now I can choose between all sectors: basic industrials, capital goods, consumer durables, consumer non-durables, consumer services, energy, finance, healthcare, miscellaneous, public utilities, technology and transportation. Then I can choose how many random stocks I would like to generate. The program skips over the stocks that didn't exist 1 year ago, and it prints out all the stock tickers with their yearly percentage changes. At the end, it also draws a graph of how your portfolio would move throughout the year. I generated 10 lists of 100 random stocks from all sectors, 10 lists of 100 random stocks from 1000 most valuable stocks, and 5 lists of 100 random stocks for almost every sector. Then, to check how the returns changed based on how many stocks we generate, I made 5 lists for 10 stocks, 25 stocks, 50 stocks and 200 random stocks. The first 10 lists of 100 random stocks from all sectors had the following yearly returns: 1.54%, negative 5.78%, negative 10%, negative 5.31%, negative 0.92%, negative 9.73%, negative 14.71%, negative 14.5%, negative 12.75%, and negative 1.61%. The average change would be negative 7.09%. In the same period, the Nasdaq fell by 0.56% and the S&P 500 rose by 13.11%. Next, we have 10 lists of 100 random stocks out of 1000 most valuable stocks, with average yearly returns of 18.33%, 13.85%, negative 65.38%, 14.5%, negative 70.78%, 50.68%, 36.73%, 49.29%, 12.94%, and 60.49%. The average return would be 12.07%. Now I'm just quickly going to go over the results from different sectors. 100 random stocks from technology sector fell on average by 17.95%. From public utilities sector rose on average by 2.74%. From miscellaneous sector fell by 17.54%. From healthcare sector fell by 39.56%. From finance sector rose by 9.5%. From energy sector rose by 53.07%. From consumer services fell by 0.93%. From consumer non-durables fell by 7.49%. And from capital goods fell by 2.2%. Now we are going to go over lists with different sample sizes. So the first 5 lists of 10 random stocks fell on average by 8.39%, with the highest return at 20.36% and the lowest at negative 26.29%. The 5 list of 25 random stocks fell on average by 8.23%, with the highest return at 0.18% and the lowest at negative 17.23%. The 5 list with 50 random stocks fell on average by 8.29%, with the highest return at 1.43% and the lowest at negative 21.74%. The 5 lists with 200 random stocks fell on average by 7.17%, with the highest return at 4.02% and the lowest at 13.13%. What can we get out of this experiment? Well, by increasing the sample size, our returns become less volatile, but that doesn't mean profitable. We can also see that you would have the highest return if you bought into the energy sector, but that being said, you would have to know which sector exactly is going to perform well. We can also see that by investing in 1000 most valuable stocks, you aren't safe from bad returns, as 2 out of 10 lists were negative, and you would lose quite a lot of your money. But all in all, the returns mostly depend on luck, which makes me think that I just wasted a week researching something that should be general knowledge. First off, I just want to say that I'm by no means an expert in Python or coding in general. I literally watched one YouTube tutorial about Python and I have some experience in programming with C. Okay, so firstly I had to get a list of all stock tickers. Preferably that would be in an Excel spreadsheet. All I could find was a list of 8,358 stocks from the Nasdaq, NYSE and Amex exchanges. This list is available to download from the Nasdaq Stock Screener website, and it allows you to download the CSV file. So I did that and then I transformed it into into an Excel spreadsheet on a Conversio website. Well, you could just use the converted file, but it looks nicer if we just delete everything except the symbols. I also moved every ticker up by one row, which you can do with some simple Python lines. I used the same process to make lists of certain sectors. The only difference is that before you download the CSV file from the Nasdaq Stock Screener website, you add a filter for that specific sector. Now let's get to the fun part. So for this program, I imported OpenPyXL from random int, Yahoo Finance from datetime, and matplotlib.pyplot. The first part of the program lets you choose the parameters. So this function returns the chosen file of stock tickers to the main program. Then the next function, called generator, lets you choose the amount of random stocks that you would want to generate. Random stock tickers are generated by a function that basically checks how many stock tickers are in a file, and then it generates a random number between 1 and maximum amount of rows. This random number represents the chosen row, and the stock ticker that is located in this row is then sent back to the generator function. This function then checks if the stock existed 1 year ago, and it still exists today, so we can get 1 year worth of data. Starting date and ending date are calculated by another function that sets the date. This is extremely important because we are calculating with closing values, which means that if I just set the today's date as the today's date and want to get the closing values while the stock market is still open, I would get an error. The program would also not work on Sundays and Saturdays. So the ending and starting date are basically delayed by 1 day if it's Tuesday to Saturday, by 2 days if it's Sunday, and by 3 days if it's Monday. I hope this makes sense. Okay, back to the generated function. Yearly change of one stock is calculated by multiplying the ending closing stock price by 100, dividing it by starting closing price, and then deducting it by 100. The average yearly change is calculated by summing up all the yearly changes and dividing them by the amount of random stocks. And the last part of the program is the graph. This was quite tricky, as I couldn't find an equation that would let me generate an average graph for multiple stocks. So I did some thinking and made my own equation, which probably already exists, but I just couldn't find it. So the variable D represents the amount of money I would want to invest in a single stock. K represents how many shares of one stock we could buy and is calculated by dividing D with the starting closing price. Ticker history represents a list of all closing prices in a span of 1 year. Variable chart is a sum of all lists of historic prices multiplied by their own K. To get the percentage change graph, we just divide the variable chart by the amount of random stocks and then deduct it by D. I'll leave the links to all the tutorials and sources in the description. If you enjoyed this video, it would mean a ton to me if you liked and subscribed. If you have any questions or recommendations, leave them in the comments down below, and thanks for watching.